Okay, so welcome back. Now I want to show you something that if we look at the Pythagorean theorem, we can figure this out another way. Now it's not probably the most straightforward way, but it's another way to do this. Okay? So what if we just took the definition of what sine means, right? Well, we know that sine theta is opposite over hypotenuse, right? So we know we could say 3 is the opposite side and 7 is the hypotenuse. So if we just drew a reference triangle, right? Which means, and we have theta here, and we have 3 and 7, we know that this is 3 and this is 7. Well, we could use the Pythagorean theorem, right? Not the Pythagorean identity, but the Pythagorean theorem to say, okay, well, I'm looking for what? This, right? Well, if I use the Pythagorean theorem, I know that what? X squared plus 3 squared equals 7 squared. And so that means x squared equals what? If I subtract 3 squared from both sides, I get 7 squared minus 3 squared, which is going to be what? That's going to be 49 minus 9, which equals 40. Look familiar? Now if I take the square root, I get x equals plus or minus the square root of 40, which gives us plus or minus 2 times the square root of 10. Okay, now that's this side. Now, what they want us to find? Cosine of theta. Well, what's cosine of theta? Cosine of theta is adjacent over hypotenuse. Well, that would mean that it's equal to x over 7, which is plus or minus 2 root 10 over 7. And again, because it's in the second quadrant, it's going to be minus, and we get the same answer. Okay, so this way was using the Pythagorean theorem. The other way was using the Pythagorean identity. Just thought that was interesting. Have a great day.